Hi, I'm Cheryl Leach. The problem we're going to be working on today involves finding the average rate of change of a function over an interval. And then later on we're going to talk about something a little different called the instantaneous rate of change. So let's begin with a function. f of t equals 3t plus 5, and we're going to be looking at this function on the interval from 1 to 2. Right? I'd like to find the average rate of change. Well, I'm going to add a little notation here. I'm going to let y equal f of t. Okay? Now, when you think of the average rate of change, you want to know how this function is changing over an interval. Think of it as looking at a video. What's happening from one time period to the next time period? So the average rate of change is equal to the change in y all over the change in t. So since I'm looking at the interval from 1 to 2, my change in y will be f of 2 minus f of 1, and my change in t will be 2 minus 1. So to continue this calculation, I have to evaluate the function when t equals 2. So I will have 3 times 2 plus 5, and then I subtract what happens when I plug 1 into my function, which is 3 times 1 plus 5. And that's all divided by 2 minus 1, which is 1. So with a little more calculation, I can find out that this is 6 plus 5, or 11, and this is 3 plus 5, or 8, all over 1, for a grand total of 3. So my average rate of change is 3, okay, over the interval from 1 to 2. Well, I promised you something about the instantaneous rate of change. So how's the instantaneous rate of change different than the average rate of change? Well, if the average rate of change is like looking at a video, the instantaneous rate of change is like taking a snapshot or taking a still picture. What's happening at this precise moment? And for the next part, we want to find the instantaneous rate of change at the endpoints. So we're looking for instantaneous rate of change. Okay. And to find the instantaneous rate of change, we're going to use the derivative. So the instantaneous rate of change is f prime of t. Well, the derivative of my function is the derivative of a sum, so we'll take the derivative of 3t, which is just a 3, and then the derivative of 5, which is 0. So my instantaneous rate of change is 3. Now, I was interested in the instantaneous rate of change at the endpoints. So let's see what happens at the endpoints. At t equals 1, f prime of 1 is, well, let's see. There's no place to plug in a t. F prime of 1 is simply 3. At t equal 2, f prime of 2 is also 3. In this particular situation, the instantaneous rate of change at the endpoints happened to be exactly the same thing as the average rate of change over the interval. This won't always happen, but in this particular case, it's exactly what was going on. I hope this helps. Thank you.